Now we're going to move on to a new topic, multivariable limits. So if you get a 3D graph plot and plot this function, you're going to get this surface. So what is the limit of this as x and y heads towards 0, 0. 0, 0 is the origin. So as x and y heads towards the origin, what is the limit of this function? So imagine you're an ant. You have to head towards the origin. So remember, this is the domain. It's a 2D x y domain. This is your surface here. It's in 3D. So this is your x-axis here. The way it's drawn, this is your x-axis. This is your y-axis. This is your z-axis. So the origin is actually right here, because the way this is drawn, you've got to look at this grey shaded area here. That's your so this is your x-axis. This is your y-axis, and this is your z-axis. So the origin is actually here. So when you look at the way this is drawn, you've got to look at this grey square here, and then the origin is actually somewhere around here. Okay, so in your mind, the domain, which is your x and y 2D plane, as you head towards the origin, so it doesn't matter how you head towards the origin. The idea behind the limit is that it must satisfy in all directions. So you could, if you're an ant, you're walking around like this. If you're heading towards the origin, you have the right to walk in this manner, as long as you head towards the origin. So if you're an ant, let's say you start here, as you're walking around like this, where will you be heading as you head towards the origin? So the height will be, in this case, it will be 50. So the limit here would be 50. But remember, the strange thing about 2D, 3D limits is that it must satisfy in all directions. So there earlier, I approached the origin in a spiral. You have to also satisfy you approaching in straight lines. You see, if you head towards the origin in straight lines, in this case, you're heading towards 50 if you're heading in straight lines. Or you could head towards the origin in a quadratic manner, x squared manner. So like this, or like this, or like this. So in which case it will look something like this. You see, with this surface, no matter how you approach the origin, in any direction, you're always going to head towards 50 in this case. But be careful when it comes to multivariable limits, because there are many cases where if you head towards the origin in a straight line, it will lead you to a height of, let's say, 25. But then when there are surfaces where if you head towards the origin in a quadratic manner, it will lead you to a different height, a height of, let's say, 21. So you have to be careful. In this case, the limit here is 50, because no matter which direction we head in, we could head into a cubic manner if you want. So hang on. So we could head towards the origin in this manner. So y equals x to the power 3. Yeah. So you could head towards the origin in this manner. Or you could head towards the origin in this manner. Well, the point is that no matter how you head towards the origin, the limit, all the heights must be the same. So let me give you another example down here. So in this case, remember the origin, you got to look at this grey square here. The origin is somewhere around here. This is your x-axis, this is your y-axis, and this is your z-axis. So the origin is somewhere around here. We know that dead on 0, 0, the whole thing will break down because the denominator will be 0. But if imagine you're an ant, you're walking along. If you're walking along the origin, remember the origin is somewhere around here. if you're an ant, you're walking. Look at this. You're walking uphill, 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 and then here you're approaching the origin. Remember, the origin in your mind. You've got to picture this. Your domain is x, y, and x. This is the origin here. If you're walking uphill, and then here you're heading towards a height of, let's just imagine this is, I don't know, let's just say it's 50. But then if you're an ant, you approach your origin. So here you're going down here, down here. You can see that you're heading towards a different limit. This is negative 50. So here, if you approach the origin in this manner here, up here you're heading towards 50. If you approach it from a different path, you're approaching negative 50. So here the limit does not exist, because for a limit to exist, all the heights must be the same. So here you've got a height of 50, and here you've got a height of negative 50. So here they're heading towards two different places. So we said the limit here does not exist, even though you're heading towards the origin in a weird manner. Up here, as you head towards the origin, in one path it takes you to 50, in another path it takes you to negative 50. So the limit does not exist for this surface. So let me give you another example. We know as x and y heads towards the origin, we know that on 0, 0 it breaks down because you're dividing by 0. But imagine you're an ant. If remember, the origin is right here. So this is your x-axis, this is your y-axis, this is your z-axis. If you're an ant, you could head towards the origin. So you could head towards. So you're walking along on this surface. Here you're walking. It seems like you're heading towards a height of 1. So if you're an ant, you're walking along like this. So here you've got a height of 1. But then if you're an ant, you could head towards the origin. Here you're still heading towards the origin. You're an ant walking along here. But then here you're negative 1. Or down here you're heading towards the origin. But here it's negative 1. So here we say the limit does not exist, because there's a path. There exists a path where if you head towards the origin, it leads you to 1, and then there's another path that, even though you're heading towards the origin, it leads you to a different height of negative 1. So because they don't match, for a limit to exist, everything must head towards the same height. So here we say the limit does not exist. Let me give you another example. For this one here, if you're an ant walking, so hang on, this is the origin here because of this grey square here. So this is your x-axis, this is your y-axis, and the height is your z-axis. So for this surface, if you're an ant walking along, even though you're walking, even though you're heading towards the origin, here you're heading towards a height of whatever here. Let's just imagine it's, I don't know, 50. But then if you're an ant, let's say you start here. Even though you're heading towards the origin, look at this. You're going downhill into this valley here, and then now you're heading towards the origin. So here it has a different height. It has a height of, let's say, 0 here. So one path will lead you to a height of 50. If there exists another path where, even though you're heading towards the origin, you're heading towards a height of 0. 50 and 0, they don't match up. So we say the limit does not exist. Here's another example. Here, if you head towards the origin, so imagine this domain being in your mind, y, x, and this is the origin here, 0, 0. If you head towards the origin in a straight line, it will lead you to a different limit. So a straight line would probably look something, I don't know, something like this. I don't know. It goes up and then somewhere around here. But the point here is that in this case here, x and y, if you approach it in a quadratic manner, so you've got a ridge here. If you head towards the origin in this manner here, you're going to have a different height. Let's just imagine this has a height of 50. But then if you head towards towards the origin in a straight line, it will lead you to a different limit. It will lead you to a different limit. So heading towards the origin in a quadratic manner will lead you to a height of, let's just imagine it's 50. If you head towards the origin in a different manner here you head towards the origin, but then your limit will, well, not your limit, your height will be let's say negative 50. But then if you head towards the origin in a straight line, it will lead you to a different limit. So the point here is that here you've got a height of 50. Here you've got a height of, I don't know, negative 50. If you head towards the origin in a straight line, it will lead you to, I don't know, let's say a height of 10. So here, up here, you've got a height of 50, 10, and negative 50. So here the limit does not exist. For the limit to exist, no matter what direction you head towards, they must all head towards the same height in order for the limit to exist. Okay, so I will give you some more examples in the next video.